Hello, everyone. I'm sorry not to be there. Thanks for having me. Let me move my slides to the correct monitor. So welcome to getting started with the Micronaut framework. Who am I? My name is Sergio del Amo. I am based in Spain. I am a Micronaut framework core committer. I have been involved with Micronaut since its inception, and I am currently the Micronaut development lead in the Micronaut Foundation, which is a foundation basically whose mission is to advocate and fund the development of the framework. So thanks a lot to the sponsors of the foundation, and thanks for the conference for having me. So what's Micronaut? Micronaut is a JVM framework. It's open source. It's licensed with the Apache 2 license, so no strings attached. It's a JVM framework which allows you to build applications in either Java, Kotlin, or Groovy. And for Java, Micronaut 4 supports Java 21 and Java 17. If you need to support Java 11, Micronaut 3 supports Java 11 still. So the latest, both the latest two LTS are supported by Micronaut. When did Micronaut start? Micronaut has been around since, I think the first Micronaut 1.0 general availability was released in 2018. So it has been around already for almost 5 years. So actually more than 5 years. So it's been around for a while, used by many companies in production. So it is a modern framework, but it's kind of an already established framework. What kind of applications can you build? You can build any kinds of application. Don't be fooled by the micro prefix in the Micronaut name. You can build microservices applications. You can build monolith applications. You can build CLI applications. For example, how many people who build CLI applications? You can build functions which you're going to deploy to Lambda or to serverless solutions. So any kind of applications, we like to say that is a kind of a foundation technology. What's the deal with Micronaut? So Micronaut is kind of a new take. So the original development team in the framework had been around with other open source frameworks such as Grails. Micronaut is kind of a second take with all the lessons learned. So it essentially it's kind of a paradigm shift in the sense that we try to do as much as possible at build time. We like to say the phrase that Micronaut basically uses smart build compilers, but no so smart runtime. So the idea is to do as few things as possible at runtime and do as much as possible at build time. And that basically means that your applications will be less resource hungry when you run them, and they will also start way faster. And this has a heavy impact, not just when you go to production, but also during development. An application that starts fast will basically empower you to write more functional tests, etc. So as I was telling you before, Micronaut does as much as possible at build time. And what kind of things do Micronaut do at build time? So we generate, for example, basically what Micronaut does, it will at compilation time using a standard. So when using Java, you will use the standard annotation processor API. When using Groovy, you will use an AST transformation. And when using Kotlin, you will use either Java annotation processors via the KPT, or you will use the KSP support that Micronaut introduced in Micronaut 4.0, which is the Kotlin symbol processing. But essentially, with the standard supports for the different languages, we will generate bytecode that will sit alongside your bytecode. So we will not modify your bytecode, but we will generate additional bytecode. And in this additional bytecode, we will essentially capture information required to allow us to do dependency injection, to allow us to do configuration injection. We'll generate like AOP proxies. We'll generate metadata about bin introspection so that we are able to instantiate classes without using reflection. This is kind of the magic sauce that powers Micronaut serialization, which is a reflection-free serialization engine, and essentially everything that we can. So as much as possible, we will do at build time. What don't we do at runtime? So we use no reflection, we use no runtime proxy generation, we don't do any class path scanning, we don't do any dynamic class path loading. So this is kind of a different approach in terms of how to power a framework. As its core, the framework is a dependency injection engine. We support the JSR 330 annotations. So those are the at inject, the at singleton annotations, so standard Jakarta annotations for dependency injections. We support, of course, configuration injection as any framework. We support properties files. We support YAML files. TAML, we support Groovy or config4k if you are really deep into the Kotlin ecosystem. In terms of validation, we have two flavors. We support either Micronaut validation, which is a subset of the Vim validation specification, or a Micronaut Hibernate validator, which essentially exposes you the Hibernate validator, which is a reference implementation of the Vim validation specification. We have a great AOP programming model, which allows you to create for example, a round annotation and do all the interception at compile time, no reflection needed. The framework also ships with a great HTTP client. Again, two flavors. One of the things that you will see in Micronaut is that it is quite agnostic framework. The HTTP client has a low-level HTTP client and a declarative HTTP client. What do I mean by a declarative HTTP client? That's an HTTP client where you essentially write an interface, and Micronaut at build time will generate the implementation for the interface. This is the same pattern that will happen when you use Micronaut data, which is the persistent solution, which is this repository pattern where you just write an interface at Micronaut at compilation time generates the implementation for you. We have two flavors of the HTTP client, one based on Netty and another one based on the built-in JDK HTTP client that I think was released in Java. I think it was released in Java 11 or Java 9, if I am mistaken. So yeah, two flavors. How do you build the applications? You either use a Gradle or Maven. For a long time, we didn't have even a build plugin because Micronaut was relying on the standard Java Notation Processor API, but we have two plugins. We have a Micronaut Gradle plugin and a Micronaut Maven plugin, which gives you like a couple of nice of life improvements to kind of boost the developer experience. So essentially, either Gradle or Maven. In terms of testing, you can use JUnit 5, you can use a Spock framework or CodeTest. You choose whatever you prefer. In terms of reactive libraries, we are quite agnostic as well. We have integration with RxJava 2, RxJava 3, and Project Reactor. Under the hood, we use Project Reactor, but all the public APIs, they essentially expose. When there is a need of using a reactive API, we expose a publisher. You don't have to use reactive programming if you don't want to. So the framework allows you to write reactive programming if you want to, but you don't have to. You can use all your code in imperative style, and that's completely fine, and that's completely... that's kind of my cup of tea, what I prefer to do. Cloud agnostic, we have integration with all the major cloud vendors, AWS, Oracle Cloud, Google Cloud, Azure. We have great integration, for example, with all the serverless solutions, so you can deploy to AWS Lambda, you can deploy to Google Cloud Functions, to Azure Functions, to Google Cloud Run. Really interesting. You can use Micronaut in places where typically Java was not possible before, such as all these serverless solutions. GraalVM, Micronaut has an amazing integration with GraalVM, in part because Micronaut is kind of a match made in heaven for GraalVM. So with GraalVM native executables, you can use reflection, but you have to whitelist the reflection usage, and this sometimes can be a bit cumbersome. However, because the way Micronaut works is we don't use any reflection, you essentially can generate a native executable of your applications without any configuration on your side. Hopefully, I am able to show you in a demo how to generate a native executable of your applications and how easy to do that. In terms of runtime, we see with several runtimes. Again, this is kind of the agnostic theme. The default runtime is Netty. Under the hood, it uses Netty, but if you need or prefer to have like a server runtime, we support also Tomcat, Undertow, or Jetty. And when you go to AWS Lambda, for example, you are not using any of those. We have you have the same developer experience, but we are essentially translating all the Lambda HTTP request events to our HTTP layer. You don't have to build a Micronaut application that is kind of a server-facing application exposed in JSON. You can have a Micronaut application which is a pure Kafka listener. We have great support for messaging solutions. You can use Kafka, you can use RabbitMQ, you can use NATS, you can use MQTT. Broad supports. In terms of database migration, we have two solutions. One is either to use Leaky-Base or Flyway. And in terms of persistence, we have probably the jewel of the crown for us is Micronaut Data. Micronaut Data comes in several frameworks. We have a Micronaut Data JPA. With Hibernate, we have Micronaut Data JDBC, which is my preferred solution where you will use a lot of repository pattern. We have Micronaut Data MongoDB, and then we have other integrations. For example, we have an integration with Eclipse Store, with Redis, with Juke, Neo4j. In terms of views, so if you are in a team that prefer to render server-side HTML, because you are building a monolith or you want to use these technologies such as Turbo or HTMX, we have a great module for render server-side HTML with integration with template rendering engines such as Timeleaf, Handlebars, Rocker. We already have support for Turbo, and in Micronaut 4.4.0, which will be released next week, we are adding integration with HTMX as well. In terms of tracing, so if you have a microservices architecture, we have a great integration with OpenTelemetry and Zipkin and Jaeger as well. Service discovery, if you want to use service discovery, you can, for example, use Consul, no problem. We have a security module with session-based authentication, basic authentication, cookie-based authentication. With JWT token, for example, we have great support for remote validation of JSON web key sets, integration with OAuth 2. You can have like an authorization code grant flow with OpenID Connect. You can use client credentials flow. So anything that you are expecting from a security solution should be in Micronaut Security. In terms of errors, by default, Micronaut errors are represented with BMB error, but you can plug, for example, problem JSON, which is, for example, my preferred error representation. And if your company needs a different error representations, we have an API to essentially extend that and use whatever error handling you prefer. Many more. So the framework is quite robust, and we have a lot of integrations. We have more than 60 modules. So these are just a few. So if you need email, we have Micronaut Email with integrations with Postmark, with Amazon Simple Email Service, etc., etc. We have, in terms of search, I saw there were a couple of talks about search in the conference. We have integration with Elasticsearch, and Micronaut 4.4.0 we integrate also with OpenSearch, integration with Kubernetes, with GraphQL. And we have a great module for generating OpenAPI documentation of your application at build time. I will hopefully demo this. In terms of routing, how do you code? How is your developer experience? Two flavors. You can choose to write your endpoints using essentially creating a class, a controller class, annotating the class with controller, annotating your endpoint methods with @get, @put, @patch, similar paradigms that you may be used to if you have used Spring Boot. Or you can use JAX-RS. So if you prefer to use the JAX-RS API, we support that as well. And with this in place, I want to do a demo. So this was kind of just to get us warm. So let me create a browser window here. So the home of Micronaut is micronaut.io. And we have a lot of tutorials. So if you want to get started with Micronaut, I recommend you to go to Learn Guides. And we have like step-by-step tutorials, more than 100 tutorials. You have, in all these tutorials, you have applications that you can download to your computer. This is the complete solution. So you should be able to be up and running in no time. As a side note, we use all these sample applications to actually functionally test the framework. So whenever we release a new version, these applications are essentially built with the latest version as well. So let me generate an application. So I'm going to come here. I'm going to do JDevSummit demo, for example, or conference demo. I'm going to generate an app. I'm going to go with the defaults, Java 21, or Java 17 is supported as well if you need that. Java, I'm going to go with Java, Gradle, Kotlin, and JUnit. I'm going to click Generate Project. We have many features that you can select here, and they essentially will change how you generate the application. I'm going to go with the vanilla default one. And let me show you what you can do. In terms of developer experience, let me do here Java conference demo. I'm going to drag and drop this zip file that I just downloaded to my IDE. We have integrations, great integrations with IntelliJ IDEA and also with Visual Studio Code. I'm running here IntelliJ IDEA Ultimate, but I could be running the Community Edition as well, and it will be completely fine. So I imported a Gradle project. If you prefer to import a Maven project, that's kind of the same idea, the same experience. You can run your application as you will normally do like a Java application. You just click here the play button. Let me actually go into presentation mode, sorry. And you can just click here the play button, or since we are using here the, let me do one thing. You can just execute the Gradle task, Gradle run, and that will run the application. The application started in a little bit around 250 milliseconds. So if I go to localhost 8080 in my browser window, we have it here. I'm not going to see anything because we don't even have a controller. So I'm going to see the default error page of a Micronaut application. So nothing fancy to be seen here. So let's, of course, do like a hello world demo. And I'm going to try to show you different things so that you kind of get an idea of what is the developer experience with a Micronaut application. So I'm going to do here hello world controller. By default, I am going to be able to write my routes using the add controller annotation, the add get annotation. So no JAX-RS. If you wanted to use JAX-RS, we will have to add an extra dependency. So I'm going to go here and I'm going to treat this class with add controller. I'm not going to add anything. So this is going to be the default. By adding anything, I mean in the annotation value. This is a get endpoint. I'm going to return a map of a string object. I'm going to do here. Then let me resolve the map import, and I'm going to do collections, singleton map, message hello world. And if I now run the app again, we should see now a hello world as we see in the browser. So nothing fancy. This you have seen this 1,000 times. Let me remove the exclamation mark so that I don't make a mistake when I do the test. So let me show you a test. So how do you test in Micronaut? One of the difference, if you are coming from other frameworks that you will see Micronaut, is that Micronaut, you test the real deal. So you don't need to like create a test slice or anything, because starting Micronaut applications is really fast. You can just start the whole application and test it. So I'm going to do home returns hello world. This is a JUnit test. So I have to annotate this with, with a test. And I'm going to inject here an HTTP client. So I told you before that Micronaut has a built-in HTTP client. So I'm going to inject an HTTP client, which is pointing to the root of my application. And I'm going to get the blocking HTTP client. The default HTTP client will return publishers, and in the test, I don't care about that. So I'm going to return the default one. And now I can do here a retrieve because I only care about the body. And I'm going to assert that the response is equals to hello world. Let me run the test and see if the test passes. And indeed it passes. So nothing fancy, but you saw a micro test, a real test, no slice. This is a functional test of the real application running pretty fast. Of course, you probably don't want to return a map. You may want to return a pollo. So this application is using Micronaut serialization. Let me show you one thing. So when I told you that we generate extra bytecode, so I have a class here annotated with that controller. And as you see here when I compile my application, extra classes are generated by me, which live alongside my application code. So this is kind of the magic of my code. We are generating extra bytecode to power your application. So I'm going to come here. We are using Micronaut serialization. So I'm going to create here a message. You can use a record. because we are modern Java developers. I'm going to do here a message. Was I calling it message? Yes. I'm going to message. When you use micro serialization, you have to opt in. This is kind of a security measure of micro serialization. You have to opt in and annotate the classes that can be serialized with observable. If you don't have control of these classes, you can import these classes using an annotation called serialimport as well. So with this in place, I can just come here and replace this with message, right? And I can do new message and do hello world. And my test, which if you remember was testing that this JSON was being responded by default, should still pass. Let me rerun the test and let's see. The test passed. So Micronaut by default responds JSON. This is kind of, yeah. You can, of course, respond other things in your controller. You can respond to HTML, you can respond to XML. But because we like to say that we assume that the best default is to return JSON by default, that's kind of what the framework does. Perfect. So I just showed you serialization. We support two flavors of serialization. Either you use micro serialization, which is kind of a drop-in replacement for Jackson data bind. You can use micro serialization with the Jackson annotation, so you could use here a JSON property. That's completely fine. I am just basically creating a JSON property with the same so that the test still pass. But you could use that, or you could use micro Jackson data bind if you prefer to do that. So we support both. We are basically defaulting to micro serialization because we think it's kind of a more in line with the framework, trying to avoid reflection and doing a lot of things at build time as well. But you can use the other as well. So I'm going to show you how to use configuration injection. So I'm going to create here a class called appconfig. I could create an interface and create immutable configuration. I'm just going to create a class just to show you. And I'm going to create here a class called appconfig, getters and setters, nothing fancy. And here you can use the configuration properties annotation, which if you have worked with Spring Boot, this is exactly the same annotation and the same idea. So I could come here and do app, resources, app.message, and I could do here hello world. And now instead of instantiating the message directly in my controller, I'm going to do a constructor injection. So Micronaut supports both constructor injection, it supports field injection, and it supports method injection. So I'm going to do here constructor injection. I'm going to do here a private final app config, and I'm going to create a constructor. So Micronaut will instantiate this class for us and will basically provide us an implementation, a bin of this type. And now I can do here app config get message. And if the configuration worked, if I rerun my test, the test should pass. And if it does, let's change the property to see it fail. Hello moon. And now it failed. So let me change you see here the return method here. I'm going to just run the test again, and it will be green. So this is configuration injection. We support that configuration property. We support each property, so you can have like kind of a dynamic configuration. So I told you before that we support validation. Let me show you that. I'm going to come here. I'm going to add the necessary dependencies for validation, so I kind of know them. But if you, of course, we have documentation. So if you go to docs.micro.io and you search for validation, here you have the necessary documentation to do that. So it's telling me I need this dependency and I need this dependency as well. So again, you will see that in Micronaut, you often add dependencies that go into the annotation processor class path. These are dependencies that are necessary to generate this extra byte code at compilation time. And now I can use the standard constraints annotation, the standard Jakarta constraint annotation. So I'm going to add a silly example. So my test is passing, right? So if I rerun it, it's still passing. I'm going to go here to the config class, and I'm going to say they have this annotation called pattern where you can specify a regular expression. And if my regular expression Ninja doesn't fail me, this will say basically that a string that starts with hello and then anything. So the test pass. If I come here in my configuration file and I do instead of hello, I do by world, and I rerun my test, test should fail, and we should see a validation exception, and in fact, we see it here. So it's telling me that this thing must match this regular expression. So nothing that you have not seen before. If you have used the Beam validation specification, the same idea, you will annotate your classes with the Jakarta constraints validation annotations. You will annotate your method parameters with @valid when you want to validate a POJO. If the validation doesn't pass, you will get like a constraint violation exception. So nothing that you are not used to. I'm gonna change this so that the test pass again. So I just showed you validation. Let me see what else do I have here on my notes. So I wanted to show you microdata as well. Let me show you how easy it is to use microdata. And to do that, I'm gonna do one thing is I'm gonna show you, for example, I just added validation. I'm gonna add here data as well. I'm gonna add data JDBC, which is my flavor. And by default, if I don't specify a database such as MySQL, Postgres, Oracle DB, I will get an H2 database. So I'm gonna go with that. But we have great support for other databases. And in fact, we have a great module called microtest resources, which will allow you to use a real, not a real, because H2 is a real database, but a kind of a more robust database, such as MySQL, Postgres, etc., Oracle DB, and you will run the application in a Docker container seamlessly. So I just added the necessary configuration for my database. As you see, this is the default name for the default data source. You can have multiple databases in the same application. And I'm gonna add the necessary dependencies. And let me pick them from here, and I'm gonna copy paste them in my project. So I'm gonna go to build.gradle, and I'm gonna paste them here. So the first dependency that we need is an annotation processor class path, an annotation processor dependency. So this is the microdata processor. We already have this one. We need the microdata JDBC dependency. We need the high carry dependency for the connection pool to the database. We need the driver, and that's all we need. So I'm gonna refresh the Gradle build. I'm gonna rerun the application. The test should still pass. They do. And now what we are gonna do is I'm gonna do a change, which is I'm gonna change my message. I'm gonna use a mapped entity, which is an annotation that microdata has to essentially flag a class as an entity. You can use with microdata JPA, you can use the Jakarta entity annotation, and also with microdata JDBC, you can use the Jakarta entity annotation with an extra dependency. I'm gonna go with the mapped entity. Self-explanatory. You flag a class as an entity. As you see, you can use a record here as well. I'm gonna go here and I'm gonna do generated value. I'm gonna do ID, and I'm gonna do a string ID. Or not a string, I'm gonna say long. You could have a generator, which is also, for example, a UID generator. I don't know if I have to specify this as nullable. Let me specify it as nullable for now. And now the experience is you create an interface, and Micronaut build time will build the interface for you. So I could do here message repository, and this is going to be an interface. I'm not going to implement the interface. Micronaut will implement the interface at build time, and I can extend from grad repository. The first generic is the entity type, and the other generic is the primary key. And the grad repository will give me methods, the typical methods that you will expect. So I can now inject here my message repository instead of the configuration. I can do dependency injection of the message repository, and I can do like a naive thing, such as checking if there are no messages in my database. Let me save a message. I can do here null. And then return here, I can do message. I think I could do find all, get first. And of course, I don't need to instantiate this thing. And if I run my test will fail because the JSON is going to be different. Actually, the test is failed because I forgot to add is failing to inject a message repository. So I need to specify here an annotation called JDBC repository and the dialect. My code will implement at build time, so you need to specify the dialect at build time. So now it's failing me because the JSON being returned is this one, while the JSON being expected is this one. So I'm going to come to my test and I'm going to adjust my test. So instead of assert equals, I'm going to do assert true. And I'm going to do response contains. And let me run the test again. There you go. So my code data, validation, configuration injection, dependency injection, routing. Let me show you OpenAPI. So in order to show you OpenAPI, I'm going to do one thing. I'm going to show you an OpenAPI tutorial just to show you how kind of the OpenAPI tutorials, the my code guides look like. So I'm going to open the visualize Swagger UI with OpenAPI specification. I'm going to copy these two dependencies. Again, this is a build time, an annotation processor dependency. So I just need these two dependency. I just need to annotate one of my classes with the OpenAPI annotation. This is the Swagger annotations. For those of you who have never heard about OpenAPI, OpenAPI is kind of the successor of Swagger, which is kind of a format to document your API. It's kind of has become a de facto standard of the industry. And let me see if I find it. So I have to add this OpenAPI definition. You see, this is not a Micronaut annotation. This is a Swagger annotation. So I'm going to go to my application class. And I'm going to add it here. I'm going to say conference demo. You don't even have to specify the service. Let me leave it here for now. So what I'm going to do is I'm going to run graded classes that will basically compile the application. I'm not going to run it. So this is going to generate everything at compilation time. So no running. This is all being done at compilation time. So I'm going to run graded classes. And this at build time, you saw that it's telling me actually here in the logs of the build, it's telling me that it generated this YAML file. Let me show it to you. So at build time, this generated a OpenAPI specification of my app, which essentially defines, it includes my controller endpoint. It includes the message. Basically, we are telling the controller endpoint that we are returning a message. So this is specified here. It's telling all the properties that are in the controller because I set this as nullable. This is now here set as optional. So at build time, you can generate a specification of your application, and you know that this specification is correct because it's coming directly from your code. So this that you see here on the right-hand side, I think is the visualization of the OpenAPI specification by Redoc. My code supports several visualization if you want to, if you want for your application to expose a visualization directly. We support Swagger UI, we support Redoc, we support even generating an ASCII doc of the OpenAPI specification. So check the OpenAPI specification module because it's quite amazing. And another thing that I wanted to show you, let me show it to you, is how to generate an native image of your application. So first of all, so I am running here Java -version. So I'm running the Corretto Java 21. So I'm going to run here Gradle shadow jar. This is going to generate a fat jar of my application. I'm going to do Java-jar. So let me show you first one thing. The application is not currently running, right? So I'm going to run Java-jar build libs. I'm going to run the fat jar. The fat jar started in half a second, more or less. And if I run it, of course, I can see the hello world demo. So I'm gonna stop the fat jar and I'm gonna run a Gradle native. So I'm gonna change to a Java. So I'm gonna do here Java Graal 21. So I'm gonna select a Java distribution. So I'm gonna select the Oracle Graal Java 21 distribution. So if I do Java minus version here, you see that I am running the Oracle GraalVM 21. And now here I'm going to do a Gradle native compile. This is basically running a Gradle task of the GraalVM native build tools Gradle plugin, which is applied transitively to your application by the Micronaut application plugin. And this is going to take, and it's going to generate a native image of my application for my operating system. So I am running now in macOS ARM. So this is going to generate a native executable for my application. This is going to take around a minute maybe in this computer. So with a subcall, I don't know. So let's see how long it takes. But one of the things that you are going to get is the application is going to start extremely fast, and the application is going to consume extremely low memory. So native executables, they play really well with Micronaut. This demo, for example, is using Micronaut data, Micronaut OpenAPI, Micronaut validation, a lot of parts from Micronaut core, all the dependency injection, configuration injection engine. And as you see, I didn't provide anything special. So this is kind of works out of the box. Micronaut doesn't use any reflection. So you will get that for free. If you need to provide reflection configuration because you are using a third-party library that uses reflection, you can absolutely do that. So the native MX executable generation finished. So now if I go, the application is no longer running. I'm going to start my native executable. So if I do pay attention because the native executable starts quite fast. So I'm going to do a demo. And this starts in 39 milliseconds. And if I go to my website, you can see that the application started in no time. So generating a GraalVM native image of your application is honestly a no-brainer with Micronaut. Micronaut and GraalVM are kind of a match made in heaven. I don't know how much time do I have yet. I wanted to do something else. If someone has any questions, please let me know. Hopefully someone can pass me those. I wanted to show you another thing, which is how easy it is to go to serverless with Micronaut. So I'm gonna, before I show you how to generate an application using the Micronaut launch, now I'm gonna show you how to generate a Micronaut application using the CLI. So I'm gonna go here, I'm gonna do AWS Lambda demo. Okay, this is already exists. I am here running the Micronaut command line interface. Let me show you the version. This is MN version, I think it is. So I'm running the latest one, which is Micronaut 437. So I can do MN create AWS Lambda. And this is kind of an interactive prompt. Tell me, how do you want to write your application using controllers, kind of a functional style with a handler. So if you should work with Lambda, this will be more familiar. I'm going to go with one, because this is kind of the idea that I want to show you, that you can have your same code and ship it to Lambda without changing the way you program. I'm going to create an Amazon API gateway. I'm going to distribute it as a fat jar. I could distribute it as well as a GraalVM native executable, but this will take a little bit longer to build. So I'm going to go with the jar. I'm going to go with ARM because my architecture here is ARM. And I'm going to generate infrastructure as code. I'm going to say yes. I'm going to go with Java, JUnit, Gradle, Java 21, no additional features. I'm going to say Lambda super demo. And my app is created. I'm going to, we generate a bash script we will deploy. I'm going to start deploying it. While this thing deploys, I'm going to open it and show it to you. So we generate two applications. This is a Gradle multi-module build. So two modules. One is the application that's named app, and it has a hello world controller. So, but as you see, nothing Lambda specific. This is a controller the way you used to work with controllers. Application class, configuration, nothing fancy. Lockback. Micronaut uses SLA4j with lockback under the hood. And in the infrastructure as code module, we generate infrastructure using Amazon CDK. And what do we generate in this sample application? We generate a Lambda. We are using actually here I don't remember if we are generating already with using. I don't think we are using Snapstart, but we support the Snapstart well. So we are generating a Lambda, we are generating an API gateway, and we are essentially proxying from API gateway to the Lambda function. And we are essentially outputting the URL into our console. The script that I executed before is nothing fancy. It's just building an optimized fat jar. This is another model called Micronaut AOT, and is essentially running a couple of CDK commands to generate the infrastructure, and then is essentially testing. Actually, we use this to test the integration that the output, the Lambda deployed to API gateway returns actually hello world. So this thing finished. The application was deployed to this API gateway endpoint. And this is already returning hello world. So this is a Micronaut function deployed to Lambda in no time, as you saw. And this is all I have. Hopefully there are any questions, and I'm happy to answer them. So in terms of Spring, one thing first is the programming paradigm is quite similar, and it's really easy for Spring programmers to go into Micronaut. As you probably have seen during the talk, if you are familiar with Spring Boot, they are similar concepts. The same, the routing is created, the configuration is pretty similar, the way you create the beans, all of that. The programming paradigm is pretty similar, and that's intentional because Spring does a lot of great things, and we didn't want to reinvent the wheel in things that work well. In terms of under the hood, the way the framework works is quite different. While Micronaut does most of the things at build time, Spring does most of the things at runtime. So Spring will use class path scanning, it will use runtime proxy generation, it will use a lot of reflection. And that basically means that the same application written in both frameworks, the Micronaut application will start faster and will consume less resources. That's the main reason. The kind of the approaches in the frameworks are different. While Micronaut goes into the build time, Spring does most of its power, most of its functionality at runtime. And this causes a couple of things. For example, in terms of debugging, Spring Boot stack traces are really huge, while Micronaut stack traces are really small. And this will help you, for example, in debugging. In terms of developer productivity, the fact that the applications start way faster, it means that you will write more tests. So one of the things that you have seen if you have worked with Spring is that the application startup time is basically really related to more code. So the bigger your application gets, the slower the application is to start. And that basically means that you will write less and less end-to-end tests. In Micronaut, it's kind of the opposite. You no longer are constrained by kind of the testing pyramid where you have most of the things in unit tests with a lot of mocking. You will find yourself writing more functional tests. So at least that's what I see in myself and in other people using the framework. And another thing that you will get in Micronaut is you will get a lot of early feedback at compilation. So I didn't show you, but in Micronaut data, you can create methods and they will be implemented for you, but the validity of those methods will be validated at compile time. So if I, for example, if I say find in this message class had a message field, if I instead of message I say find find a title, it will fail at compilation time. It will tell me you don't have any field with the name title. So it will have like an early validation feedback loop, both in Micronaut data, also in routing. So we have like a Micronaut HTTP validation, which will basically validate that the routing is correct at compilation time. So you get an early feedback loop. But the main difference at the end of the day is kind of a philosophy. So while Micronaut does most of the things at build time, Spring does most of the things at runtime. And that basically means that Micronaut applications will be faster to start and less memory hungry. And this will especially show in big applications.
I've played around a little bit with Graal native image, and there are some things that it does that are counterintuitive from the standpoint of a Java developer, such as static initializers will execute sometimes at compile time unless configured otherwise, as well as any calls from JNI into the Java land have to be explicitly declared either in a configuration properties file or within a feature. I'm curious how often you find developers writing code that use native image versus FatJar, and how often these limitations actually end up posing a non-starter for those that decide to write a new Micronaut application.
So we don't have any data about how many people you actually. So I see GraalVM native executable as kind of a deployment option for the framework. So you have many deployment options. One is to generate a FatJar, as I showed you. One is to generate like a Docker image of your application. One is to generate a native executable. Another one is to generate a native executable inside of a Docker image. Another one is to use MyCode Crack, which integrates with Azul Crack. So there are different deployment options. GraalVM is one of them. As you said, GraalVM is not without caveats and without things that you may need to. So you are going to need to understand the things that you described. You probably are going to have to provide some extra reflection configuration or some initializations. So MyCode, we see people using GraalVM. We see it in terms of support tickets, in terms of issues. My recommendation always is try for your application. If it works, great. You're going to get the extra performance boost and the extra low memory consumption. But if not, a regular Micronaut application deploy as a jar file is pretty fast and pretty is not really hungry in terms of resources. So that you should be fine. So I always see like GraalVM as kind of to kind of get the extra mile. It's especially nice, GraalVM, in scenarios such as Cloud Run, Google Cloud Run, or AWS Lambda, all these serverless scenarios where startup time is especially important. This kind of where GraalVM shines for me. But the developer experience in terms of using GraalVM and MyCode should be as good as it gets. We have kind of a couple annotations to help you produce some reflection information when you need it. I'll give you an example. For example, I use a lot of times TimeLeaf in my applications. TimeLeaf will use reflection to do essentially the server-side rendering of the templates, and you have to whitelist those reflection usages of TimeLeaf against your classes. And that's typically means that in MyCode you have like a class with some annotations telling like these classes are reflective access. But yeah, as you said, you have to understand the limitations of GraalVM, and more than the limitations, the way of workaround of the closed word assumptions of GraalVM. No problem. Thanks for having me.
We have one last question, but just a quick one, okay? Because we have
how it's working with the Java agents, instrumentation agents, and such stuff? Should we do something additional to support them?
Lombok? Did I understand? Is the question, do I have to do anything additional to support Lombok?
No, to support some Java agents. Let's say we did the jar with the Micronaut application. Is there something additional that I need to support, for example, New Relic agent for it, or it will work?
I see. I think I think New Relic, for example, if you use, getting back to the previous conversation, I think the New Relic agent and GraalVM will not play well. But if you run a normal Java MyCode applications with New Relic agent, I don't think there should be any issues. I myself have not tried the New Relic agent with a MyCode application, but in theory, not. There should not be any issue. But I have not used it myself, so I don't know.
Okay, thank you very much. Thank you for your time.
No problem. Thanks for having me. Bye-bye.